Okay, so different regions, different challenges, and I start by my own. I transfer into data center without anyone helping me, and I suffer a lot until I stand on my feet. I hold a bachelor degree in electronics and communication engineering. I'm currently pursuing my master degree in the data center leadership at Anglia Ruskin University, UK. I am approved as a DCPP provider with the CPD standard office. Gustavo, please, can you keep it mute? You keep unmute yourself. I think you're joining from different devices, and that causes some echo. Why I started with my background. I did not burn as a data center engineer. Gustavo, sorry, Gustavo, please control the mute of your device, please. I did not born as a data center engineer. I did not spoon-fed the data center. I learned the hard way to go into this industry. And I want you to do so. Everyone can do that. Now, let's start about 3 myths. Myth number 1. Okay, myth number 1. You need years of data center experience before you can work on one. This is a myth. All right? That's something not real. The reality, building the skill, transfer directly to data center delivery. Whatever you know currently, whatever you have currently, that works for your industry. Let me ask a question for the attendees. I see someone just joined. Hajar? Hajar, you just joined? Okay, I think there's an issue. Gustavo, can you tell me what's your background? Gustavo, can you hear me? Guys, is there a problem with the sound? Because I think people are not hearing, or what happened? Zishan, you answer that you can hear. Can you hear me? Okay, Zishan can hear. Can you talk, Zishan? Just tell me what's your background. Are you like planning engineer, commercial engineer?
Basically, I'm a mechanical engineer with a background
Great,
in thermal power plants.
great. So Zishan here is a mechanical engineer. Maybe he never worked in data center. I'm just assuming. He never worked in data center. He thinks that data center is a rocket science. He needs years and experience and certificates to become a data center engineer. I can tell you this is completely wrong. Zishan, if he's a mechanical engineer, Gustavo, I think the problem with you, honestly, because the other guys can hear, so maybe you can check your setup or something. I saw your in the chat you're saying you cannot hear. So Zishan, he's a mechanical engineer. He knows what is the chillers and how the chillers are designed. He know how to calculate the CFD. He know what is the CDU. So Zishan, in a principle, he knows everything that works inside the data center. But what he needs to know, he needs to know the context of the data center. What is important? What does it mean is a mission critical? What are the tier standards? What are the terminologies that he needs to use? Other than that, he has the 80% knowledge of data center without even knowing that he knows data center. I have Ali here. Ali sent me his resume. Ali is electronics engineer with the fiber knowledge, etc. So Ali is someone who knows exactly what is going on inside the white space, the racks. Maybe he doesn't know. He worked somewhere, but he can just get the enough guidance to transfer into this industry. So that's number one. What you already know is valid is around 70, 60, 80, whatever percent of the data center knowledge. You just need to know how to channel it or channelize it in the right direction to know more how to use what you know and build this one together. The DC specific contest, as I said, is less than 20% of the project. Okay, when you build a data center, because this is one of the problems that I need the people to understand. Whenever I go ask someone what is data center, he said it's IT building. It's not IT building. The purpose of it, it's built as an IT. It will be operated by the IT team, but it's not IT. You don't need to be IT engineer to work in data center. Data center is a building that has generators, that has chillers, that has PDU, that has CDUs, that have cables, bus bars, etc. Data center needs civil engineers because it's a building. It has superstructure, substructure, finishes, and all of the cladding, facade work, infrastructure work. It needs electrical installation engineers who install the cables inside. So data center is not an IT. When you, as a construction engineer or having any kind of construction background, when you enter into the data center, until you leave your scope, the building scope, 2 years more or less, you have no interaction with the IT. IT team is the hyperscaler, the end user who's going to be used and operate and who will stay. Like the hotel, for example. I'll give you a small example. You are building hotels. All of us, maybe you have in our experience, we work in hotel or school. You don't need to be an hotel operator to work in hotel construction, or you don't need to be a teacher to build a school. The similar concept applied here. You don't need to be IT engineer to work in data center. Data center is a construction building that has a lot of MEP, but you need to understand how it works, how it serves, what is the purpose of this building, so you can design, work, understand, prioritize things in the right direction. Now, the second myth, which I already talked about, you need to be an IT, computer, science background, computer engineer, software engineer. Not. It doesn't mean they don't work in data center. They are the people who will use the data center. They are the people who will run the data center, who will operate the data center, who will stay for 10, 15 years inside the data center, who will furnish. If you look at the picture behind me, this is the white space. The white space is the racks, where the racks are installed, where the data center core is the white space. But before you reach this white space and install all of these servers and racks, etc., you are building just another building. Not exactly another, because there's other people. The first people who said you need years until you can enter the data center. The other people said it's just another building. Why you make it complicated? Both are wrong. It's a building. You can build it. You have the knowledge to build it, but you need the extra 20% to know the context of the data center, how it's built, why it's important, what does it mean. We will explain a little further here. So the IT side is the client side. And the client is Google, Microsoft, like Azure from Microsoft, AWS, Amazon, any other hyperscaler that are using the data center, Meta for like Facebook and WhatsApp, the other Chinese GDS they want, or whomever. They are the IT people. They work. They like Microsoft, for example. They don't have mechanical engineers, electrical, civil engineers, planning, contract, commercial. But they hire people or companies to build this for them. And this is your next role. You should target that role. All right? 100 megawatt, like 100 megawatt campus, which I told you it's around $1 billion. So you can imagine what are the salaries, what are the roles are involved in this building. 90% of it, it's MEP, coordination, civil building, mechanical, planning, procurement, 90% of it. 10% is the IT integration. And for the people who are coming from this like construction background, they're not involved in the IT at all. At all. You need to expand to know more. You can go there and expand your knowledge, but you don't need to be an IT engineer. Now, the third myth, data center are niche, separate from construction. It's something not a construction. It's rocket science. It's like medical care help. Not completely not. Data center is construction. You are constructing a data center. You are building data center. You are designing data center. You apply for permits for data center. You approach authorities to get the approval. You are connecting power for data center. You are doing furnishing, installing, do exactly what you do for any building, just in a different sequence, different priorities, different scope of work, but it's the same. It is exactly the same. Hyperscaler, higher construction professional first. Then, like when you need to build, you need construction professional first. Then the IT people, the software engineers, that comes later. And data center industry, it is just construction with one extra lens. It's construction, exactly construction, but it has different kind of requirement. It's similar when you work in a high-rise building. You need to have different knowledge than when you work like in horizontal villas or whatever. You have mechanical floors, you have different pressure pump, different structural calculation, different construction methodologies than when you work, for example, in villas, than when you work data center. You just need to understand the context. You can build it. It's fine. Now, let's have the 3 skills that you really need. Number 1, I'll talk in the life cycle of the project, the life cycle of the data center project in a brief. So, and allow me to use the whiteboard. Fine. So, we are going into 3 major, let's say, stages, umbrellas that are covering the data center lifecycle. Number 1 is the design. So you first design, and design is very important in the data center. It's not similar to the normal construction, because here design drive commercial, design drive construction, design drive the handing over. So whatever you do in the design, it's going to be your Bible for the next few months or year or whatever of the project. Any change in the design, it cannot be accommodated easily as you accommodate the changes in the normal construction. That's number 1. Then you build building that includes civil, MEV, installation, inside, outside, white space, gray space, and these terminologies that are things that you need to know. And it's not difficult when we say white space, gray space. Gray space, simply the infrastructure area, the back of house. White space is the picture in my background. This is the white space where the revenue generated, where the data center built for. This is what called the white space. But you need to understand what is it, when it will be handed over, what's going to affect it. Then the handover period. These are the major 3 periods into the normal construction. I said data center, but not. This is the normal life cycle of a normal construction. Design, build, handover. But what's happening inside the data center? Here, it's a bit different. Why? You start with something called feasibility. However, I work as a developer before in the real estate, and there's feasibility in the real estate, but it's a different. The feasibility here in the real estate, just you calculate your revenue, profits, timeline, etc. Here, you need to start first with the plot selection. How you choose the plot and why? What are the requirements that you need to check? What is the relationship of the power? Why you need to ask about the power and fiber before you ask about the price or any other requirement that you do, road or a prime location or whatever. So first, you start with the feasibility and the site selection. And here, you cannot just assume. Here, where you decide to invest millions or even billions on this project. What's your role? Electrical, mechanical, planners, contractual, commercial, all of them, they have something to do here. So if you are on the client side, you have a role, you have something to do in this stage. Then the planning, and the planning here, it doesn't mean planning like a Primavera and P6 and timeline. Planning that you are planning what you're gonna do, planning the phasing, planning your client, planning the tier standard, planning the timeline that you're gonna deliver, etc. Then you design. Because now you have the plots, you have the limitation of the plot, you know what power you're gonna have, what kind of water, because data center and a data center are using power and water. The small building of data center, it can use power and water similar to the consumption of a high-rise building. And this is a small data center. So you need to understand that. You need to understand the resources, the power and the water that you have, what kind of power you are going to get, HV or MV, what are the connection timeline, the agreement, before you do everything. Then you design. Once you not complete, while you are designing, you need to start the procurement. And the procurement here, majorly, is the long lead equipment, LLE, long lead equipment. Muhammad on the call, can you explain to me, like, what's your background? Muhammad Abdel Bari?
Yes, Assalamu alaikum.
Alaikum assalam. Can you just tell me just your title, like your background, mechanical, electrical, planning, whatever?
No, I am a lead electrical, ELV, and ICT engineer.
Okay, thank you, Muhammad. So let's come to Muhammad case. He's electrical engineer and ICT engineer. What he does here in the feasibility, he will do like a major. Muhammad, you can mute yourself. That's fine. I just need to have an example.
Okay.
Major decision for the feasibility is around the power. So electrical engineer, he will be asked the first question. This is the power. What is the power that we need to have to this facility to run? The question from the management. The answer, it depends on what we are doing. So I need to know my tier standard. I need to know my POE. What's POE? Power usage efficiency. What does it mean? What is the IT load versus what is the gross load? So Muhammad or any other electrical engineer here, he would say that as per the authority, we have 100 or 150 megawatt MVA, and our POE, it's assumed 1.5. So we can produce 100 megawatt campus. At the same moment, the fiber engineer, the ICT engineer, will study the fiber route, how many operator we have, how many carrier we have, what is the nearest connection point, and what is the latency and other technical terms. This will lead the design in the later stage. The design itself, when you have all of this, after stage 2 in the design, you will fix the capacity, area, layout, needs for the generator, etc. So you start your procurement. Why you start your procurement here, and this is from the client side. This is also different. This is something called OFCI, owner furnished, contractor installed. In the data center, the owner starts purchasing, procuring the long lead equipment. Zishan, you are a mechanical engineer. You want to work on the site. Which time you start like purchasing the chiller? At which stage of the project?
Basically, I work in thermal power plants, but we decided at the basic design stage, once we lock the basic design, then normally the procurement starts.
Correct. But this is on the contractor side. This is on the, thank you, Zishan. I just need to have some experience from the people attending. This is from the contractor side. But in the data center, the client is not waiting for the contractor to be hired to start the procurement. We are talking about facility that need to be built between 20 to 24 months and even less. I myself contribute to building a data center in 18 months because the speed to market is very important. It's different than the real estate. And the revenue generation, it starts after you start the operation. So every month of operation delay is generation of revenue delay. It's a different story here. So the client will start the procurement before even procuring the main contractor. Like we start procuring generators, PDU or distribution unit. CDUs, chillers, UPS and batteries, depends on the design, any other major long lead equipment before even we start completing the stage 4 or 40 design to start the tendering process of main contractor. So we, in data center, we purchase and start the procurement process of the equipment before the contractor, which is not the case in the construction. Why? Because maybe in one tower, I work in 60 floor towers, and we procure one generator only as a backup generator for the emergency batteries and fire alarm and main exits and etc. In the data center, small building, like 20 megawatt, we purchase 10 generators. 10 generators, lead time of it is 12 months because there is big demand now on the data center equipment. So the contractor, the developer doesn't have that luxury to wait for the contractor to be hired. Then the contractor start the procurement, then start waiting for 12 months. Cannot. This is something major to understand. Now, you know how to procure. You know how to use the specs to procure. The commercial team know how to do the procurement, but you need to understand the context when I procure and why. Now, everything you know, you just put it in the context, when and why. You are a data center engineer, simply. Then build, and here sometimes we do it in phases. We have 2-3 contractors, early work, structural work, like CSA, civil, structural, and architectural, then MEP. And the MEP here is the main contractor. That's something we are not used to in the normal construction. MEP is the major subcontractor. The weight of it is around 30% of the contract. But here, MEP is the main contractor. Go to the contractors, like whomever is joining here from Gulf region, BK Gulf or other NARSCO or something, they are MEP contractors. But they are main contractors in the data center context, similar to Europe, the US, the UK, whatever. Then commissioning. And commissioning here, I have electrical engineer, I have mechanical engineer on the call, and that's very nice because what we do in the commissioning, metering test, leak test, light test for the duct, pressure test, other firefighting test, and we do it when we don't care about it. We keep doing it while we are handing over. We do it after the PCC. Sometimes things goes beyond the TOC into DLP. It's fine. One flat, they have a problem in the FCU, even if the tenants occupy the flat, we can fix it for him later. It's fine. It's not the case in the data center. The major part in the data center is the commissioning. There is no data center without completing L2 to L5. What is L2 to L5? This is the context that you need to know. You know how to do commissioning. You know the specs. You know the requirement, but you need to understand what is L2, L3, L4, L5, when and why they are important, and why the commissioning is planned in the design stage. Actually, the commissioning is planned in the design stage. That's not something come by default. You understand? Now, pre-design planning is where most of the projects fail or succeed. The pre-design. That's why I said design. The design here, I don't mean the calculation, the SLD, single line diagram, and the load calculation, etc. No. It's majorly for the people who work in design consultation or developer side. They know what's stage 2. The people who are familiar with REBA stages, they will know what's stage 2. It's the concept. So what you freeze in the concept, it's what's going to lead the remaining of the design, procurement, build, and commissioning, and your data center. This is not the case in the real estate, the normal construction. So you know how to design, you know what is the design, you know what's the outcome of the design. Things are a bit different here. Okay? Now, let's go to skill number 2. Speak the language. Data center has terminology. They are not Chinese for the people who speak English. You just need to understand them. You know the basic. So everything inside the data center, when we say its capacity is 100 megawatts, 50 megawatts, 60 megawatts, what does it mean? This is the IT load. What does it mean again? What's the racks? These behind me, and I intentionally put this background for you people to know. What is the power what is the power consumed by this room, by the racks. So this building, the white spaces, the data hall consumed 50 megawatt of power. So this building called a 50 megawatt data center. What is the white space? White space is the place where you place the rack, where you place the racks. And this is where the data center works. This is where you generate money. You are not generating money from the generators or offices or any other place inside the data center. You generate the money for the developer. They generate the money and the operators from this room, where they hire and lease it for end users. And also the end users like whom? Like bank. Who's the end user of the data center? The bank. Any transaction you do now, the call now we are doing, the Zoom itself, they purchase something from any other operator, like any cloud services. And this cloud service is stored in data center. The phone call you are doing every day, the Netflix you are watching, the YouTube, the SMS that you receive, the ATM, any online transaction, anything happening on the internet, it goes and stored inside the data center. So I just need you to imagine what is data center. You think it's a building in the desert or something comes new. It's not. The ChatGPT, when you are talking to ChatGPT, asking a question, when it said it's thinking and giving you an answer, the real thinking happening inside one of these phones. So this is data center, and this is why it should be up and running 24/7. You cannot like have this like inside the real estate. You can close part of the building and renovate it. If there is a problem in one flat, you can maybe like evacuate the tenants and fix it, or fix it while they're there. In data center, you cannot. You cannot stop WhatsApp for like 2 or 3 days because you need to do maintenance at the data center, or it goes off because the power has issue. So that's the difference. And this is the white space. What is the gray space? Yes, Mohammed.
Actually, I have here a small question about the IT load. You mentioning that we are calculating the load based on the power delivered to the IT equipment. What about the supporting facilities like the HVAC loads, as an example? Because normally in the construction,
I got your question, Muhammad. And this is the next box, the BOE. This is the BOE.
Okay, thank you.
Here. Just let me catch it. This is the BOE. So white space is the power, is the rack. Okay? Gray space is the whole infrastructure, the whole building. What is BOE? BOE, it's power, usage, efficiency. How efficient you are in designing your data center. It equals to gross power to IT power. So if I consume at my boundary level, at the facility boundary level, at the meter, I consume 100 megawatt. But inside the racks, I'm consuming only 50 megawatt. Okay? So I have 100 gross over 50 IT. What is my PUE? 2. And this is very bad number inside the data center. The closer to 1, the best efficiency, because the rest of it is a waste. The difference here, what does it mean? You are consuming exactly the double, or like similar to what you are using inside the data center. You need to deliver the power to the white space, and be efficient outside the white space as much as you can. Supporting, like you said, chiller, HVAC, lighting, securities, any other instrument or lifts or whatever inside the building. Now, in the world, it's between 1.3 to 1.5. This is the optimum. Depends on what? Depends on the region. That's number one. In Saudi, in Iraq, in UAE, or wherever, it's no way can match the BOE in Finland. I worked in Finland. There we can achieve easily 1.1, 1.2. Why? The temperature there is different. Inside the data center, inside the white space, you need to maintain 18 to 27. This is the optimum C, centigrade. This is the optimum temperature inside. In Finland, this is most of the year, they are not like the most days of the year, if not all of the year, they are not hitting 27 outside. So they don't need to run the chiller. They can do air-cooled, simply air-cooled, ambient cooling. In Dammam, you cannot. It's 40, 45, or 50, 7 months in the year. So first, it depends on the location. Second, depends on the design. Liquid cooling, hybrid cooling, air cooling. It depends on what, like what they call it, the generative power. If you are generating from a wind farm or you are generating from solar or whatever. So this is the PUE, Mohammed, answering to your question and also aligning with other people here in the session. So these are some of the terminologies that you need to be familiar with, even if you are a civil engineer, but you need to understand what is PUE. Okay? Coordination. The skill number 3 is the coordination. The data center is a game of coordination. We are talking about around 18 months, too many activities running together. We have operation team, end user who gonna use the data, like the data center itself, civil engineers, MEP engineers, all together with authorities, with other requirements. So you need to manage this coordination. And the planner is the translator between these three. And the planner, I don't say planner like the planning engineer. Whomever is there who needs to be like having a pivotal role inside, he should know how to coordinate when, what, and why. That's very important. Okay, long lead equipment, the procurement of it, MEP IT integration, the commissioning sequence, the activities. For example, you keep following up the generator, because generator is very important, need to be installed. You cannot have your commissioning without the generator. So you push for the generator procurement, you push for the generator installation, you push for the generator contractor or supplier to be attending and the MEP to install, but you forget very small detail that you need to complete the work outside, the infrastructure outside, and to build the gantry as a very small steel structural element that you like where you install your generators. You may forget that, did not coordinate well between MEP and civil and the other people, and that causes you months of time and delay because you don't coordinate this small detail. And there's many other details that I already have it in my course. Now, all learnable. What I need to tell the people, all are learnable. You can easily excel and penetrate the data center industry with your current knowledge. It's not a computer science. It's not IT. It does not require that. You are a mechanical engineer, like Zishan, what he said, he can easily work in data center. Mohammed is an electrical engineer, he can easily work there. Ali is ICT engineer, he can easily work there. And there is a demand. Forget data center as operator. Like if you are in Saudi, for example, forget the human, forget STC. If you are in the UAE, forget DO, forget Etisalat. These people, they need ICT engineers. If you are in America, AT&T or Microsoft, whatever. But who build these facilities? Normal contractors. Contractors, designers, MEP engineers. You just need to understand the context, what you can do. Now, what we do put together, sources scattered across hundreds of papers. And there is a problem. Easily, if you go to search now, anything related to the construction of normal real estate construction, you'll find thousands of courses, papers, video, YouTube. You can easily learn. We all learn that way from the site experience, and we just go to any like blog or course or something, we can get so many information. This is not the case in the data center. Ask me. I started saying my background because I need to tell you guys, I learned the hard way, really hard way. When I entered the data center and I just pushed into data center, I was in a company, a major developer, they just worked into it, like they decided to open a data center branch, and that was very new to the market here, a few years ago, not even now. And I just handled the portfolio management. I need to know. I enter meeting, I hear words that I don't understand. POE, like what I said now, a gray space, white space, and I feel shy after 15 years of experience, director level, and all of this knowledge. I find myself inside the meeting. I don't understand what's happening. I go outside, search online. I couldn't find anything easily. No structured learning path. There's so many certificates in the data centers, not as much as the real estate, of course, but I take them. I taught them already. I studied them already. All of them are general knowledge, which is very good. Which is very good for someone who doesn't know anything. It's very good to know. But does these or do these courses prepare you to work on data center with a real case scenarios? I don't think so, because I tried it myself. They'll give you knowledge, fire, installation, etc. Mostly it talks about design and operation, but not real case scenarios. There is no single course in the world that tells you need to bring the LLE, long lead equipment, at this time, and after stage 2, and after stage 3, nothing. What is the challenges? What's the operation? How to coordinate between contractors? Nothing. It's all about design, general knowledge, and operation. So it took me myself years in different 7, 8 countries with 2 gigawatts of portfolio, dealing with Microsoft, with Google, with OpenAI, with different people. So I learned it the hard way. And this is exactly why I decided to build the Data Center Planning Professional, DCPP, which I wish that was exist 10 years ago. But I can easily just go and see someone who can talk me, guide me, mentor me, and I can use my own knowledge. The 20%, which I start the course, this session with, you need 20% to know. This is the 20% that I believe I would be happy and glad to have them 10 years ago. What is DCPP? In a brief, DCPP, Data Center Planning Professional. This is the first data center life cycle in the world. When I say in the world, because it's accredited, and I search for it, I contact even CNET and Uptime, EPI, which I have connection with. They don't have such a framework. It's 8 sessions online on Zoom, recorded. If you miss any call, you can watch it later. CPDCO. What is CPDCO? This is the CPD Standard Office, the UK, accredited. We have, thankfully, just few, like the past week, we have accreditation from the CPD. That's 16 hours continuous learning approved with every certificate for the attendees. We have people graduated from cohort 1, and they were so happy. I'm glad that I delivered the message. For me, it's a message, because I was like a director. I was hiring people. I spent 3 months, 4 months just to find one planning engineer to join the team, and I couldn't. We end up hiring people from the UK, Ireland, and other places with extra salaries maybe, or they don't even understand the context of the Middle East. So I wish the people here to know that and join and take this opportunity. And now it's mainly UAE, KSA, even Oman and Qatar. They are taking major steps into the data center industry, major steps. So don't blame anyone later when you see this is the major industry in the world and you are left behind only working on villas and towers. That's what I'm trying to tell everyone. So cohort 1 completed. We have people who joined from different companies, different background. I have people from UK, Canada, the US, Saudi, Iraq, and UAE. So far, also, we have good amount of people. So we have only a few seats left already. Who joined? Planning engineers, project managers, electrical, mechanical. I have QA/QC. We have development managers. We need to understand the feasibility, the land selection, etc. Real estate, like commercial team, who need to understand the procurement process, the design process. All of them have joined, because it's not designed for a specific people. It's designed for everyone inside the data center to understand the full life cycle of it. What we have today, because of this course, the normal price of the course is 1,750. But for the sake of the people who attended this session, we have a promo code that's valid for the next 24 hours only. You can register, scan. If you have your phones with you, you can scan the code. It will direct you to the registration link. You can easily, and it's fully automated. There's no like a wire transfer or a transfer money or something. It's payment gateway. You can have your terms, conditions, refund policy, everything online. You just use this code in the next 24 hours. So you will get this price. After that, from 24 to 48 hours, the discount will be 10%. Use this code. Take screenshot, guys, or something if you are interested with this price. The normal price is that. Use this QR code to take you to the landing page, or follow this link, or you came from LinkedIn, so you can just go to my LinkedIn. You will find a lot of this information that I have just mentioned now. Just I need one thing to tell you guys. Let me remove all of these drawings. I am always available. Whether you join or you not join, I need people to understand, people to learn, people to understand that this is the future. I try to limit the discussion to maintain the time. There is a lot of papers, documents, etc. that I always, even my LinkedIn, I always posting to tell you what is the data center, what is it in the future. Scan this QR on the screen. You will have my company WhatsApp, and I'm also managing from time to time the WhatsApp. You will find my email, my LinkedIn, website. Whenever you have a question, you need something, you need to understand, whatever comes to your mind, just approach me and ask. It has nothing to do with the course or you need to register or whatever. However, the people who will join the course, of course, there is WhatsApp group, there's continuous discussion and open discussion always. They can approach me easily. We have Q&A after each session. We do Q&A. Sometimes we do just like casual Q&A in the middle of the week or something. We just open 30 minutes, a call for Q&As. The people from like cohort 1 till now, they send me WhatsApp, they send me questions, answers, we talk together. That's fine. But apart from that, you can always contact me when you need help, you and anyone else. Just refer to anyone else in your team who need to know. Now, we are 7 to 10, so we have like 7 minutes. Q&As, guys. The floor is open. Any question if you have. Again, guys, the floor is open.
Firstly, we're glad to see you after years in this location and this position, and now to send your experience and guidance in this way and situation. It's glad, and would like to thank you about this information. Besides that, my idea regarding the data center facility, the primary purpose, I think, of it, it's to provide a secure, reliable, and also continuously available environment for processing, storing, and also delivering services to the client. That's the 20% that you mentioned in this session. So I very thank to this session, and nice to meet you, Mr. Baha. Thank you.
Thanks, Ali. Thank you, Habib. Thank you very much. You and everyone else, you can approach me every time to like shout your questions. People on the call, this is like, let's say, the last chance. If you have any other question, other than that, approach me every time you want. So any other question, or we close the session? Asif, I saw you are unmute yourself. Go ahead.
But so you gonna take the session, or you have a basically team who will take the session?
No, it's myself. So far I don't trust anyone to deliver this on my behalf, and
Okay.
also To be honest, I enjoy it. I enjoy to talk to the people, have these ideas and chat. So I'm the one who's gonna be leading the sessions. I don't have any other instructor in the team. So for the rest of the team, I'm just like administrator and this stuff.
Okay, so these are basically planning on data center planning. You are saying how this course is different than ATD, CDCP, and CTDC.
So that's a good question. CDCP, CDCP, CDCE, and the other from CNET and Uptime, ATD, all of them focusing on the design. General knowledge. CDCP is the most general one. Just explain to you power, raise the floor, etc. CDC will take a step further. ATD will have more like calculation and stuff, and it's not even a design. Like it's not real design calculation. What is the difference? As I said, I don't know if maybe you missed part of the session. This class is not a technical class. This is not technical. I'm not going to explain to you how to calculate your bus bar or how to calculate the volume of air or of a humidity inside. It's not me who gonna explain to you that. I'm explaining here how these are linked together, how these are connected together. What is the importance of these? So it's most like framework, life cycle, management, decision making with real life examples. So inside the course, I cannot cover everything here in 1 hour. The course itself is 16 hours plus Q&As. It will be around 20 hours. So I cannot cover it all in just like 30 minutes. We have a session called engineering. In this engineering, we explain the gateways, the design standards, the tier standards, and why everyone is different and what's gonna change. I'll give you an example. You have a brownfield. Brownfield means a data center that's already fitted out. And the question came that we need to change it into AI. It was a cloud, CPUs. They need to do GPU retrofit with CPU, of course, GB300. So this is the GB300. This is the requirement of the cooling, because majorly everything is driving the cooling, then etc. The question comes to you now. You are a mechanical engineer. You are handling the site. We need to refit or retrofit the site to accommodate the GPU standard. How many racks you can install? Sorry. Now, what we are explaining, how this domino effects works. Now, I'll give you this example. You need to change from CDU, like cloud data center. What does it mean? Rack density of 10 kilowatts to GPU, GB300 or GB200 or AMD or whatever. It's around 100 and above. Let's say 100 kilowatt. So the rack that was handling or can compute 10 kilowatt, now it's able to compute 100. What does it mean? The facility that I'm having now, the space that I'm having, the white space, which was responsible to produce 10 megawatt, can produce now around 100. Not exactly from 10 to 100 is 10 to 100 because there's other calculation, but for the sake of the argument, we have 100 megawatt. What does it mean? I have PUE. What is my PUE? PUE is 1.3. But wait, that was the PUE of the cloud. Now we have changed the design to GPU. What is the cooling requirement of NVIDIA for their GB300? The cooling requirement is 80-20. For example, 80 liquid cooling, that's the D2C, like direct to chip, which is the plate on the motherboard with liquid cooling, plus 20, which is hybrid, 20 air cooled. To run the facility, we need extra 20%. So before, it was 100% air cooled. How many chillers I was using? For the sake of the argument, no technical numbers here, 10 chillers. But now I need chillers to cover the 20% only, plus the chillers that are going to provide and circulate the cold water to the plate. So my 10 chillers now become 4. For example, and I'm achieving the same tier standard. It's tier 3, the design. Okay, now I have 4 chillers instead of 10 chillers. So I reduce the power from the chiller consumption, right? However, I have increased the power consumption because we said the rack density goes from 10 to 100. So how these all together works, how all to give a final decision. So you need to understand how to calculate the power, but not only the power, because the people with normal knowledge, they will say, okay, 10 kilowatt become 100 kilowatt, so I need X, like times 10 power. It's not, because you change the infrastructure itself, the full infrastructure. You change the chiller, AHU, FAHU, CDUs, other infrastructure. What you have changed, that will be detected or produced to your power consumption. So at the end of the session, when you put all together, when you understand how this works together, you can give the final question, even if you are just a mechanical engineer. You said, guys, this is my calculation, but the power changed. You need to calculate the new power requirements for the chillers, for the new circulation pumps, etc., etc. My POA changed. This is the new power I want. This is a simple example. What is the difference between this session and other sessions and CDCP, CDC, whatever? No one tell you these examples. They give you the concept that you need to calculate power, you need to calculate, but no one gives you what does it mean all together. What is my power requirement with the authority? I signed for a power of 100 megawatt. If I need to change now, ask for 150, might take me 2 years. So yes, I can change, but after 2 years only, because there's power requirement. I myself in Athens, just to get extra 3 megawatt in Athens, they said you need 12 months because they need to do full installation and redesigning of the city power connection to allocate you a spare load of 3 megawatt. 3 megawatt is just 2 rows or 3 rows of those racks.
Which, Baha, this course basically more aligned with the greenfield or brownfield, or this combination of both?
Both. We talk the concept. We tell you this concept. So this concept I just tell you now, it applies if you have a brownfield. It applies if you have a greenfield. The management told you, like, we have a greenfield. We need to give me options of a cloud, and this is happening all the time. I need a flexible design. That can be, I myself, my previous companies, we did that. We still did not contract any hyperscaler. So we don't know what is the requirement of them. We don't have a customer, but we need to design. So we do a flexible design. So
I agree with you, but you know what? Generally, what you are talking about, that decision has to be taken at the really top level. People like us who are really going to break into the data center, they are mostly basically gonna be engaged with the like MEP engineer or maybe planning engineer, manager or something like that. But this sort of things will already been decided, and all you have to go and just execute the design.
No. Allow me to say no. Why? The top management decision, they take the decision, they don't calculate.
Okay.
They don't calculate. You calculate. What's your background?
My background is civil engineering, but I'm in project control.
Well, like what's project control? Exactly. This is my previous, like my initial background. All of what I have just explained to you now about brownfield, greenfield, all of these, you as a planning engineer, you need to calculate the time and path of all of these decisions. So when it goes to the management, it doesn't go that I need to purchase extra generator. It goes as a full business case. I work with the chairman. I was reporting directly to the chairman, and I know how this management works, and I know how the decision cascade down and goes up to take these decisions. You need to go back to him, tell him, if you need to change from cloud to AI, you need to purchase 1, 2, 3, 4, 5, 6, and this is the cost of it. This is the impact of it. This is the time of it. Who do this? Procurement engineer, planning engineer, mechanical, electrical, civil, on the ground. You are a consultant, you're a contractor, or whatever. You do it on the ground. You give it to your management. Your management puts it all together in a business case and raise it up. The chairman or CEO or VP, SVP, they don't calculate how many months I need to take to purchase a new generator. You do as a planner. I am a planner. I work in the site selection before we even select the site. They come to me. We have 100 megawatts. Power comes at this time. Generators comes at this time. Build for us a program, because you need to build a program before you purchase the plot to build the data center.
That's how it is basically in mission critical. But anyways, okay, these costs basically how much you're gonna cover the risk part involved with the data center as well as procurement delays. Somehow, it's a procurement driven. Basically, long lead item is LLA is going to be part of this. Apart from this commissioning and IST. So in these whole your program DCPP, how are you going to cover all of this thing, or you are just going to be touch the base of all this thing? How do you approach?
No, we are going to into modules. If you see the plots below, there is feasibility module. Feasibility, the site selection. First, we start with this data center, kind of data center, different type of data center, just normal knowledge. Feasibility, site selection, technical due diligence, fiber, how to use it, what are the chances of failure, what are the hidden paths in each and every one. We don't go straightforward. Straightforward, I need 2 sessions to explain to you straightforward. Why it's 8 sessions instead of 2? Because I have a word that I always say, a sentence that I always say. The data center plans for failure, not for success. You need to plan every single failure scenario, not success scenario. And villa, you build the villa. Just you need to plan what is the best way to build the villa. That's it. But you don't plan when the villa is demolished, when the villa hit by rocket, when the villa flooded. You don't do that. You assume this is normal case, normal building. I just need to people live inside. In the data center, you plan everything. So here where we cover scenarios. So in feasibility, we start how you choose the site. What are the major difficulties, challenges, problems, issues, hidden issues? You know what's hidden issues? I'll tell you what's hidden issues. You know, for example, in Finland, when you need to build a data center, and mostly it's forests, so you need to cut trees before you start. Once you get your approval on the plot, you start cutting the trees because you need to remove the trees. If you don't know that there is a risk called environmental risk that you need to get approval to obtain that approval to start cutting. Otherwise, you cannot do anything. And if you don't know that they have 3 months of bird nesting season, they have kind of birds that is in these 3 months of the year, they have nesting, and you can, by law in the full country, you cannot cut any tree. So if you don't know that, you will build a program from day one will be delayed 3 to 4 months. All right. So this is what we tell you here. These cases. It doesn't mean every country has this case, but now you understand there's something linked to the environment. There's another thing called to Ministry of Defense. What Ministry of Defense will do on the purchase of a plot in data center? Nothing.
Okay. In this,
the last thing comes to your mind.
Last
then
question.
We go to design. Yeah, sir, tell me.
Sorry. In this course, basically, we have feasibility to commissioning. Okay, so are we going to be in contra with the real project, or you just give your any artificial project you will take and just walk us through, or you will talk about the real project which you have executed on the ground? Based on those, you will walk us through what the approach basically for this course.
Why I said this course is different than CDCP, CDCA, CDCO, DCTT, etc. Why I said that? It doesn't mean they are not. They are bad. They are very good. They are very knowledgeable. I taught them. I read them. I have a lot of knowledge, and I use a lot of knowledge inside these courses. But none of them giving you a real case. Here we build the program fully on real cases. So after the feasibility, I shared a real feasibility folder. After design, I shared BOD, basis of design, from a real project. After procurement, I share with you, like not with you, with the students, the real responsibility matrix, real procurement strategy, real XCR that has connection and links after the build, after the commissioning, etc. Of course, I have just do some changes to remove names, countries, any confidential information, take 3, 4, 5, 6 projects together and produce final document out of them. But it's all built on real cases. There is no theoretical here. Theoretical, CDCP, CDCP, ITD, etc. They are more than enough for people to know this. Theoretical.
Okay, makes sense. Thanks, Baha. Thanks for your time. I really appreciate.
Thank you,
Thank
Mr.
you.
Baha.
Thank you, everyone.
Nice to
Thank
meet
you for joining. Thank you. Thank you, guys.
Bye-bye. Thanks for your time.
Bye. Bye-bye.